Ready for a little surprise quiz here. 7. Name that angle. This is a what type of angle? All right, good job. Second person. How do I find what angle TBS is? Angle TBS is equal to 14. Oh, not this time. 13. Name it.
TS.
Measure of arc TS. All right, we're good. We're good. Name that angle. What type of angle am I working with here? 22. Inscribed. Good. Angle LEK is equal to 1. Inscribed angle. How do I find the measure? Arc, not length. Measure. Measure. All good. This is what's on the quiz. That's from unit 1. I mean, quiz 1. Okay, that's it right here. Central and inscribed, and I'll show you why as we move along in the day today here. I'm going to show you a third and final angle that can be built inside the circle. You got central, you got inscribed. Now I'm going to introduce to you angle ACD here. All right, angle ACD. Is it a central? Central? Absolutely not. Is it inscribed? No. So it's nothing that we talked about. Instead, what I'm going to refer to this as, it's not the official name, by the way, it's my name, floater angle. A floater angle. Why do I call it a floater angle? It's literally just floating in the circle there. Okay, so I call it a floater angle. Angle formed by 2 chords. How do I find it? Right, I know central's equal, inscribes half. Floater angle, let's just get right to it. No fancy theorem here today. Floater angle. It's a little bit more involved though, so suck it up. Floater angle. I am going to take its arc measure, add it to, here we go. Going to use a term we've used in the past before. Its vertical angles arc measure. So I'm going to take its arc measure, add it to its vertical angles arc measure. Now, why do I have it in parentheses, right? Why do I need that in parentheses? Because you're going to take that sum and cut it in half. That's how I find one of those floater angles. Go back up to angle ACD. A couple of you guys are going to find it for me right now. How do I find angle ACD? I'm going to take its arc. What arc belongs to ACD on our diagram? 3. AD. So I'm going to take arc AD, add it to its vertical angles arc. Its vertical angles arc. So ACD is vertical angle with BCE. And what arc belongs to BCE? 18.
What's the question?
Okay. ACD has a vertical angle. What's the vertical angles arc? And I'm going to cut it in half. All right, that's how I'm going to find this floater angle. Floater. Take its arc, add its vertical angles arc, and cut it in half. Questions? All right, very simple. 2 very simple ones before we start getting hardcore on you. For this first one, that is not the center where they intersect. That is not the center. All right, please don't assume it's the center. Why would I give it to you? Answer's 88. We're done. Right? Is it okay? You know it's not central. I just gave that away. Is it inscribed? Nope. So it's got to be floater. If it's not inscribed or central, it's a floater. So how do I find the floater? I take its arc. 7. What's its arc measure? Why 44?
Oh wait, no.
Angle X belongs to what arc?
88.
That's all I needed. Plus its vertical angles arc, which is 6. 86. And I'm taking half of it. Why are we using our calculators for this one? Quiz 1, you got an 88. Quiz 2, you got an 86. What's your average?
87.
Oh, look at that, kids. A little math there, huh? Fancy as that. 87. Silly. All right, number 2. And yes, this is gonna be a broken record every single problem from now on because I want to try to train your mind to think the same way. 65 degrees. Go down the checklist. Is it central? Central angle 65 degrees? Nope. Inscribed?
No.
Nope. So I'm left with floater. 65 degrees is a floater angle. Ooh, how are you going to find the arc then? 65 is the floater. What's it going to be equal to? Now use your formula. Hey, 23. What are the 2 arcs involved here? What's its arc? 100. What's its vertical angles arc?
X.
Add it to angle X and make sure we cut it in half. Hey, smart kids, as they tell me. What's your next move? Solve for X. High.
Distribute.
I could distribute the 1/2. I get nervous because I get 1/2 X. I'm like, a fraction next to a variable. I could distribute though if you're comfortable doing that. Caitlin, anything else I could do?
Multiply both sides by 2.
Get rid of the 1/2 right now. So decide what you're doing. If you're going to distribute the 1/2, go. If you're going to get rid of the 1/2, you got to multiply both sides by 2. It's up to you. If I multiply both sides by 2, the 1/2 and the 2 are gone. 130 equals 100 plus X. And then go ahead and move the 100 over. Yes. Floater angles. Floater. Anything right now, ask, because the basic is gone now. And there are no more basic problems here. Anything? Floater angles. All right, here we go. It's time to step it up, honors kids. Woo! Find angle X. Great. Remember these days? Numbers in a ratio. Most of the time we had angles in a ratio. Now the arcs are in a ratio. What did we usually do here if I had numbers in a ratio? We usually did angles. We're in this ratio. What do we do with numbers in a ratio? Remember, Serena?
Put an X in front of it.
Throw X's. I'm going to throw a Y in front instead just because we're finding angle X. And I don't want you to assume when we find X, that means that X. So is everyone all right just putting Y's in there for now? You didn't have a choice anyway. So, all right. So ABC, I'm going to label as 2Y. CD, I'm going to label as 3Y. DFG, 1Y. AG, 4Y. What do you do with all these? What can I do with all these? Because if you take a look, I got to find this floater angle X. I'm going to have to know what ABC is, and I'm going to have to know what DFG is, the degree measures of each. If I'm going to find that floater angle. What can I do with all 4 of those arcs? Dig deep. 24. What can I do with all those arcs?
Oh, yes, I don't know.
Yes, you do. Yes, you do. Do I have all the arcs in the circle?
Yes.
Okay.
Oh, wait.
Oh, come on. Yeah, now you're digging deep. Come on. I thought we had a connection.
Yeah, I don't know. You keep looking at me like I know.
You do know. That's why, because I'm not telling you, because you're going to find out.
All right, well, I'll be here for a while.
What do we know about all those arcs? What's going to come first here, an answer or a haircut from you, huh?
Okay, look.
Too harsh, anybody?
No, you're right. Don't
All
get
right.
me wrong.
You know all the arcs, Mahmood.
Right. Oh, we gotta find the angles.
Well, no, I'm not going to be able to.
All right, never mind that.
It's a circle. You know all the arcs.
360.
There we go. What can I do now?
Oh wait, that's not the length of the arc. That's the measure. Oh,
Yeah.
That makes way more sense. Okay. Like now that makes sense. Why it was confusing. Now that it's oh yeah, you just add them all up and then you're like 360. Then you find y and then you plug it all in.
Oh, now we're a superstar now, right?
Well,
Now we're a superstar. Look at me, everybody.
Degrees or something.
Yep.
How am I meant to know? That is so unfair.
Seven, 3, 10y equals 360. So we're finding out the value of y is 36. Thank you. Now, you can go ahead, plug and black all in for y, but remember the only two I need up here, right? The only two I need are angle x's arc and its vertical angles arc. So let's see, angle x, how big is that arc? Or what's the measure of that arc? Excuse me. 15, measure of arc ABC now.
2y.
2y, I know what y is now, so
So it's 36. No. 72.
72, good. So 72 degrees. What's the value of its vertical angles arc? Oh, 8. Okay, angle x has a vertical angle. What's the measure of its arc?
72.
That's angle x's. I'm looking for its vertical angles arc.
36.
36. Everyone's all good? So angle x will be equal to, tell me what to do with these numbers now. Making it tough on you. 13, what do I do with these numbers?
You have to add them up and then multiply by half.
There we go. That's how I find a floater angle. So we're all going to take half of 144. No, not even close. I don't know where that came from at all. 108. And now I end up with 54 degrees. Ooh, got rattled. You guys good? Questions on how to find that? Because they're just going to get tougher, these last two. Ready? Yep, Serena?
I'm confused.
Yep, where?
So wouldn't angle x be equal to 2y?
No. Is angle x a central angle?
Oh no.
No. So it can't be equal to its arc. That's only for central angles. All right, that angle x is a floater. So that's why I did the 72 plus 36. Good deal? Okay, a very common mistake right there. All right, make sure central angles come from the center. Anybody else questions before we just get after it? Deep breath, let's roll. Woo! King size circle problems. Get used to these. Multiple parts, A through whatever. King size circle problems. You know what I'm talking about. Usually you got the Hershey bar, but then, maybe you can spend a couple extra bucks for the king size. This is the king size circle problems. All right, this is where the level I need you to be at. First thing I'm going to tell you with these king size problems, I don't care about what they're asking for. This right up here, A through E, woo, don't care. Don't care right now. I need your help finding as many arc measures as possible right now. If you can find every arc measure, you're golden. You are golden in these king size circle problems. Find the arc measures first if you can. So let's see if you can help me find all the arc measures. AEH, follow the letters. A to E to H is $1.10. Arc AG is 80. Ooh, another ratio one, huh? AE to EH is 2 to 3. What are you going to put on AE? What can I put on AE then? 2y, 2, we can put x now. That's fine because I don't have anything else that's x in here. And EH, 3x. All right, I'm turning this over to you, kids. Let's go. Let's help each other out. Any arcs you know you can find. Any arcs up here you can help me find. I don't care how you find them. Tammy, you want to start?
Arc AE.
Arc AE. What are you going to do to find that?
So you do 2x plus 3x is equal to 110.
All right, I'll start there. I like it.
And then 5x is equal to 110.
All right, kid's a human calculator over here.
And then divide by 5.
Yeah, we would divide by 5. Yep.
And then x would equal 20.
Oh boy.
Yeah, I haven't calculated it, but 22. I
Yeah,
believe.
nice. 22. Yeah.
Yeah.
You're just gonna keep trucking.
Oh.
What do I do with that 22?
Okay. You multiply it by 2 to find AE.
Which would be then?
44.
And how about EH while we're here?
Multiply it by 3, and that would be 66.
Oh, unbelievable. Way to go. That was a mouthful right there. Way to go. Okay, Tavy spotted you 2 arcs. How about the rest? And I'll be honest, this is something a lot of kids don't see, and we gotta pick up on this. You just don't think about it. Serena, go ahead. What do you see?
So arc AEH is 110.
Yep.
It's a central arc. So AOH is 110 degrees.
So you're finding angles now too, right?
Yeah, well
Okay.
then you can do that, and then you get HOB is 70 degrees, so HB is 70.
I'm going to get to HB a different way, but yes, that is 100% correct. Listen to me, start looking for diameters. Start looking for diameters. Why do I say that? A diameter cuts a circle into how many degrees? 180. Don't I have a diameter up here, AOB? I know part of it's 110, the other part has to be, and we still get there the same way, 70. Everyone agrees? It's 180 degrees in a semicircle. I got one more arc that's missing. Any help? Paul, go ahead. Why?
Because you already have AG as 80 degrees, and then, it's 180. So
It's a semicircle. Look for diameters, please. Look for diameters. All right. We have all the arcs. We should be good to go now. Okay, we should be good to go answering parts A through E. Let's find out. Just watch how easy this problem becomes if I know the arcs and my rules. But all right, first part, A. What's the measure of GB? Oh, already found it. 100. Sometimes that's nice. You take care of about 1 or 2 of them right off the bat. Part B. What's the measure of EA? Oh, I already found it. This is not bad, huh? No thinking involved yet. 44 degrees. Oh boy. Then comes EFA. Angle EFA. Do it in your mind with me. Central? Central? Nope. Inscribed? Nope. So then, therefore, it's got to be floater angle. So now I get in my mind rule for a floater angle. 1/2 times, what's the measure of the arc that belongs to EFA? What's the measure of that one? Oh, 4? Grip? 44. Good work. Plus, now look at its vertical angle. What arc belongs to that? 11? 100. There it is, everyone. Good work. So half of 144, 72. I would also recommend putting it in your diagram because you never know. The next parts you may use 72 again. I don't know in this problem, but you may. Next up, FEB. FEB. Everyone see that angle? FEB. Central. Central, anybody? Inscribed? This is why we need to know the stuff before quiz 1, because of this right here. It's inscribed, so the rule is you take half only. half its arc. So FEB belongs to which arc? 7. FEB belongs to which arc?
GB.
Which is 100. So FEB is going to be 50. There we go. Oh, I love this question. Love this last one. Kids just go nuts over this one. OHD. OHD. Central. Central. Inscribed. Now, there might be some controversy here because some of you may say yes because you see H is on the circle. But remember, inscribed angle, what do the two sides always have to be? Chords. I got a radius and a tangent. That's not going to work. Okay, so this is not inscribed because the two sides are not chords. Is it a floater? No. It's nothing. None of them? We're 0 for 3. You can still find it, though. You can still find it. Come on, dig deep. You know how to find it. What is OH? A radius. What is DHC? Tangent. When the two meet, what ends up happening? Makes a perpendicular, makes a right angle. I don't need anything but my theorem. 90 degrees. How'd that one taste, Brendan?
It was great.
Darn right it was. But I can tell you're hungry still. I didn't feed you enough. Questions? Let's just look at that. Anybody just like, all right, I'm good. Look at that diagram. I'm out. Oh, I wish it was that easy, right? There's only really one reason I picked this one to put in your notes, and it's not because it's tough. It's because I want to remind you guys, you still need to read through everything. Because there's a little tidbit in here that you could overlook if you don't read carefully. All right, I got inscribed. It's inscribed. Great. And then what's the next one? AP. Oh, yeah. Don't want to overlook that. Name the two angles that are congruent in my diagram then. If AP bisects BAC. Two angles that are congruent. Oh, Griff, what do you think? Which ones?
BAE and EAC.
Got it. So I'm just going to put my arc marks here to remind me those two angles are congruent. I'm sure it'll come into play. And now take a look. I'm not telling you the arcs are in a ratio. The angles are in a ratio. Be careful there. Those are angles that are in a ratio. So everyone, ACB, let's plop in a 4x, right? CAB, let's plop in a 3x. And ABC, let's plop in a 2x. Woo. What can you do with all three? 180 or 360? I always get kids with this. 180, it's a triangle. I know everyone's in the 360 mode. Some of us are. But yes, 180. 3x, 2x, 4x. $1.80. $9x, 180. X is 20. All right, help me find the angles now. Talk to some more people. Like talking to you guys sometimes. 8. You want to tell me all the angles in this triangle?
40, 60, 90.
What is it?
ACB is 80.
Okay.
CBA is 40.
Good.
And BAC is 60.
Nice. 80, 40, and since this is 60, is everyone all right if we just cut it in half now? Jonathan, you all right with that? Good. I didn't care what you said anyway, but 30, 30. All right, see if you can help me out. First part, what's the measure of angle ABC? I think we found that already. That's 40. Ooh, here you go. Arc BF. What is the measure of arc BF? Arc BF. What is the measure? Not the length, the measure. I'll help you out. I'll help you out if you need it. 6.
60.
How?
Angle BAP is an inscribed angle, and it's 30, so multiplied by 2, it's 60.
Everyone see that this angle inscribed is drawn to BF. So I need to not take it, cut it in half. I'm going to double 30. Yes, good work. And get 60. 60. Angle BEP. This is why I love these circle questions. You don't need to use a circle fact to find BEP. You can find it other ways as well. And I'm just going to let you find it any darn way you want to. Angle BEP. However you want to find it, go. I don't care. You want to use it looks like, first of all, what type of angle is it? Central, inscribed, or floater? Floater. So if you want to use your floater rule, go. You don't have to. That's what's the great thing about these king size circle problems. $22. Get me there.
I said triangle AC. Angle AEC is 80 degrees.
80.
70 degrees.
One job. All right, I'm still listening.
And then angle BEP is 70 degrees.
There you go. Fine with me. Did anybody do this triangle instead, get 110 and it was supplementary? That's fine. Anybody do the floater theorem and say 1/2 of 60 plus 80 equals 70? You can do that too. All right. Questions? All right, just flip it over and get going. Let's go. Get it going. I don't want to waste time here. Yeah, go ahead, Jonathan.
Are we gonna do the inverse?
Sure, I can do it right now. As soon as you raised your hand, I was like, I just remembered, and he's going to